Hello students, in this lecture we will discuss basic definitions and probability notations. What is probability? Probability is the degree of belief in the truth or falsity of a statement. So, whenever there is uncertainty, there is a value assigned to a statement that is greater than 0 and less than 1. So we can define it as the range of uncertainty. When I am certain that statement is true, then that statement is assigned probability 1. And if I am certain that the statement is false, then it is assigned probability 0. The notation that we use is we write P of x, means probability of the statement x. And we use this type for negation of statement. So what is law of excluded middle? P of x plus P of negation of x must be is equal to 1. That is probability of a statement and the probability of the negation of a statement must sum to 1. If probability of x is 1, then obviously probability of negation will be 0 and vice versa. In general, all outcomes of a probability distribution must sum to 1. Now, what defines a probability distribution? It is the collection of statements that are exclusive and exhaustive. What are exclusive? Given complete information, no more than one of the statement can be true. For example, if it is raining is true, then it is not raining will be false. So these two statements are exclusive statements. What are exhaustive statements? In addition, the statements that make up a probability distribution must be exhaustive. And that means that at least one of the statements must be true when we have complete information. So I am sitting inside. I don't know whether it is raining or not. I assign a degree of probability that reflects uncertainty to both the statements. It is raining and the statement it is not raining. But when my information is complete, exactly one of those statements must be true. Now, it is often the case that we have more than two statements that form a probability distribution. These statements are exclusive and exhaustive. For example, distribution X consists of statements that would be denoted by x1, x2, x3 up to xn. The probability of each statement must sum to 1, which is denoted as probability of x1 plus probability of x2 up to probability of xn must be equal to 1. Now, what is the principle of indifference? For the ith outcome xi in a distribution with n possible outcomes, P of xi must be 1 over n. For example, drawing an ace of spades from a well-shuffled deck of 52 cards, what will be the probability of drawing the ace of spades? Now, there are 52 cards and there is only one ace of spades. So, the probability will be 1 out of 52, that is 1 over 52. Now, what will be the general statement for probability of an event? When there is no basis to choose some outcomes as more likely than others, then probability of an event will be number of outcomes as defined in event divided by total number of possible outcomes in the universe. So that is all about basic definitions and notations of probability. Thank you.